Hi guys, myself Sadashiva Ammar. I am currently been studying in Sri Venkateswara College of Engineering, Department of CSEI. Let's discuss today about concepts of probability theorem and its applications in real life. Probability theorem. Probability theorem is a branch of mathematics that deals with the uncertainty and randomness. It provides a framework for qualifying and analyzing uncertainty in various situations. The concepts of probability theorem have a wide range of applications in real life across various fields. Here are some key concepts of probability theorem and their applications. Probably, probability basics, conditional probability, random variables and probability distributions, accepted values and variances, law of large number and central limit theorem, statistical interface, game theorem, risk assessment and decision making. Probability basics. Probability measures the likelihood of event occurring and ranges between 0 and 1. It forms the foundation of probability theorem. Sample space. The set of all possible outcomes of an experiment is called as sample space. Events. An event is a subset of a sample space consisting of one or more outcomes. Conditional probability. This is the probability of an event occurring given that another event has already occurred. It's denoted by an p of a bar b. The probability of an event a given event b. Bayes theorem. This theorem calculates the probability of an event based on prior knowledge of conditions that might be related to the event. Applications: medical diagnosis, SAMP email filtering, quality control in manufacturing. Independent and dependence. Independent events. Two events are independent if the occurrence of one event doesn't affect the probability of the other event occurring. Dependent event. Two events are dependent if the occurrence of one event affects the probability of the other event occurring. Applications: weather forecasting, stock marketing analysis, gambling. Random variables and probability distribution. Random variables: a variable that takes on different values with associated probabilities. Probability distribution: a function that describes the probabilities of different outcomes for a random variable. Applications: economic forecasting, risk assessment in insurance, predicting exam scores. Accepted values and variance. Accepted values: the average value of a random variable weighted by its probabilities. Variance: a measure of the spread of values around the expected values. Applications: financial investment decisions, game theorem, resource allocations. Law of large number and central limit theorem. Law of large numbers: as the number of trials or observations increases, the observed frequency of an event approaches its theoretical probability. Central limit theorem: the distribution of the sum of a large number of independent identically distributes the random variable approach a normal distribution. Applications of law of large numbers and central limit theorem. Polling predictions, quality control in manufacturing, social sciences and researches. Monte Carlo stimulation, a computational technique that uses random sampling to estimate complex mathematical results. Applications: financial modeling, stimulating physical process, optimization supply chains. Statistical interface. Statistical interference, drawing conclusions about the population based on a sample from that population. Applications: medical trials, marketing researches, etc. Game theorem. Game theorem. The study of decision making in an strategical situation involving multiple participants. Applications: economics, international relations, etc. Risk assessment and decision making. Probability theorem helps in assessing and managing risks in various scenarios, aiding in making information decisions. Applications: engineering design, project management, financial risk assessment. These concepts and applications showcases the importance of the probability theorem in the understanding and dealing with uncertainty in the diverse real life situations. For science and engineering to economics and social science, probability theorem provides a valuable tools for analyzing and decision making. Here is an example of probability theorem. Sampling theorem. A coin is tossed 1,000 times and it turned out of 540 times. Decide on hypothesis that the coin unbiased. Let's solve this. Let us suppose that coin is unbiased. P is equals to probability of getting it in number of tosses. P. P is equals to 1 by 2 means off. When a coin is tossed, whether it has to get head or tail. P is a probability of getting an head means off. P plus Q is equals to 1. Q is equals to 1 minus P. Q is also in 1 by 2. Expected number of heads in 1,000 tosses is equals to n into P. N means number of times the coin tossed. And P is an probability of getting an head in one toss. 1,000 into 1 by 2, 500. Actual number of heads is equal. It's given in the question. Actual number of heads is 540. The difference is x minus np. X means it's turned out 540 times. Np is equals to 500. 540 minus 500 is equals to 40. X is z is equals to x minus np by root of n into p into q. 40 by root of 1,000 into 1 by 2 into 1 by 2. The answer result is 2.53. 2.53 is lesser than 2.58. Thank you.